NAND NOR is called universal logic gates, and XOR XNOR is called arithmetic gates. Universal universal logic gates. Universal logic gates. So here the gate is one is a NAND, and another one is a NOR. So why this is called universal? Because using these logic gates, so using these logic gates, you can design gates. Uh, we can design any other other logic gates, other logic gates. That's why it is called universal logic gates. That's why it is called universal logic gates. Now we start the designing of using a NAND gate. So suppose I'm using here NAND. So using a NAND, we can design any logic gates. So what is the symbol of NAND? So NAND gate symbol is this one. This one is the NAND gate symbol. And invert. This is called a NAND. This is called a NAND. And suppose that A and B is input, so NAND output is A into B bar. That means simply read as and invert. So and invert and invert, that is called a NAND. So now first we design using a NAND how to design a NOT gate. So NOT gate. So suppose I am using here one NAND gate, and it's the input. Suppose A and B input is short, and that's where we apply a single input A. So A is the input. What is the output? Output is A bar. So A bar. So what is the characteristic? So this one is work like a NOT gate, because the NOT gate input is A and output is A bar. Input is A and output is A bar. Now we're discussing to the another logic gate. So OR and AND. How to design OR and AND logic gates, or and logic gates. So suppose here I'm using one AND NAND gate, and it's the input is A and another input is B. So what is the output here? So output is A into B and invert is bar. So AB bar. And now again we have here use another NAND gate. So like a not. So what is the output? So if the input is AB bar, so it's the output is AB bar and whole bar. So what is the value? So this is equal to A. Use apply the De Morgan's law. No need to apply the De Morgan's law. Just A bar and A bar cancel, and its values is AB. So what is the AB? That means this is equal to AND gate. So input is AB and output is A into B. So that is the AND gate. And third, suppose that here I am using a one NAND gate. Here I am using a one NAND gate, and suppose that the input is A, and another NAND gate, it's the input is B. So A and B input, and then again here we have apply a NAND gate. Again we have apply here the NAND gate, and if here the values is input. So what is the output of this one? So its the output is A bar, and its the output is B bar. Yes. So what is the output here? So output here is A bar into B bar whole bar. and then apply the De Morgan's. So it's the values is A double bar, and here the product. So this value is sum B double bar, and this is equal to A plus B. That means this one is OR gate. So you can say using a NAND you can design a NOT gate, you can design a AND gate, and you can design a OR gate. So question is how many NAND gate is required for the designing of NOT gate. So here this one is the NAND, so one NAND gate is required. If question says how many AND gate is required for the designing of um, how many NAND gate is required for the designing of AND, so two. This one is the 1 and 2. Similarly for designing of OR required three logic gates. Now you can design, if you want to design a NOR gate, so how many logic gates is required. So suppose I'm using here a NOR. So NOR means just a simply OR invert, so you can design using like this one. So one NAND gate, and what is the value of this one. So suppose this is A, suppose this is A, and here the another NAND gate. So this is the NAND, this one is the NAND, and it's the input is B, and here you have connect the another NAND gate. So it's the input is A bar, and this input is A bar, and here the values is B bar, and output is A bar into B bar whole bar, and this values is equal to A plus B, A plus B. And once again you have connect here another logic gates, another logic gates. That one is the NAND. So what is the output here? So output is A plus B bar. So A plus B bar, this one is a NOR, this one is NOR. So what is the values? So this is OR, so OR, and then here you have used invert. So this is this one is OR, and this is invert. So or invert, that is equal to NOR. So how many logic gates is used here? So NOR, for the designing of NOR, four NAND gate is used. 1 2 3 4 NAND gate is used for the designing of NOR gate. So this one is a NAND, this one is a NAND, and again here a NAND. 4 NAND gate is used for the designing. And suppose if you want to design the XOR gate, so how many NAND gate is used? So suppose I want to design XOR. So you know the XOR output, that is equal to AB bar plus AB bar. So how to design? So just now I'm choosing here one gates, that is here I'm using a one NAND gate, and one NAND gate, and suppose it's the input is A, and it another input is B. So this is A and B. This one is the NAND gate, and then it's the output. And again here you have used the one NAND gate. Again here we have used the one NAND gate, and it's the input is this one, another input is these values, and now here we have connect the another NAND gate. So this one is the input, and just to find it what is the output. So if A and B is the input, so here the output is A into B bar, and this one is A and this one is B. So what is the output here? So here the output is A into AB bar, whole bar, and here the output is B into A B bar whole bar, and finally output, here you have find the output, that one is equal to, so you can simplify this one as it is. So apply the De Morgan's, and it's the values is A bar plus AB, and here the values is B bar plus AB. So these two values. Now the final outputs, that one is A bar plus AB into B bar plus AB whole bar. So you can write down like this. You can write down like this one. So this is equal to A bar plus AB into B bar plus AB whole bar. And you can simplify this expression. So apply the De Morgan's. So here you have applied the De Morgan. So what is the value? So this values is equal to A bar plus AB bar into, so here you have applied the plus, and then B bar plus AB whole bar, like this. Or again you can apply here the De Morgan's. So its values is A double bar is dot and AB bar, and again here the plus B double bar, and here are De Morgan's apply AB bar, and again you have write down this is A into AB bar. So what is the values? A into A bar plus B bar. Similarly, plus B into A bar plus B bar, and just to multiply this one. So A into A bar, that is equal to 0. So it's the values is AB bar plus BA bar, and this is called A XOR B. A XOR B. Since A bar, that is equal to 0, 0, or B bar, that is equal to 0. So this is called output is, so here the final output is A XOR B, and input is AB. So when you need to design a XOR using a NAND, so how many NAND gate is used? So 4 NAND gate is used. So first, second, third, and 4 NAND gate is used. 4 NAND gate is used. And if you want to design a X0, so here you can design, suppose if you want to design the X0 using a NAND, so what, how to design? Yes.
So can you go back to the slide once again for 1 second?
This one? Yes. So anyone have any problem? So if you want to design the XNOR gate using a NAND, so XNOR means simply, you know that the XOR, first you have designed the XOR and then invert. So XNOR, that means this one is the XOR and then invert. That is called the XNOR now. So this is XNOR. So suppose A is input and B is input, then output is A XNOR B, or simply this value is equal to A XOR B bar. So that is called XNOR. So how to design? So first we have designed the XOR. First, now here we have designed the XOR. I'm already designed the XOR. So first we have designed the XOR. Here the input is A and B, and then here you have connect inverter. So one NAND gate is here you have connected, and this inverter, this bubble, this is called the inverter. So you say the XOR, and then invert XNOR, and this one is connected like this. So here you have find the A XNOR B, and its the values is AB plus A bar B bar. So how many NAND gate is used? So here you have used the 4 NAND gate. Here you have used the 4 NAND gate and 1 NAND gate. So total and 1 NAND gate. So for the designing of XOR, for the designing of XNOR using a NAND, 5 NAND gate is used. 5 NAND gate is used. For XOR need a 4 NAND gate. So here needed a 4 NAND gate. 4 NAND gate is used for the designing of XNOR. And similarly, using a NOR, 4 NOR is a 4, and is 2, or is 3, not is 1. So in this way, you can design the other logic gates also. Now, suppose if you want to design using a NOR. So how to design using a NOR? So using a NOR, you can design some other logic gates. Logic gates. Now I'm taking a first example. Just suppose I'm taking one NOR gate. So NOR or invert. And if the input is sorted, and if the input is A, so what is the output? Output is A bar. So it's the work look like a not gate. So for the designing of not, one NOR is required. So basically this is not. So one NOR is required. One NOR is required. And suppose if you want to design the some other logic gates, like and or, so how to design this one? So suppose I'm using designing here, I'm choose here one NOR gate, and here the another NOR gate, and suppose these two input is sorted. So only A is the input, and here only B is the input, and again here one NOR gate is connected. So what is the output here? So output is A bar, and here the output is B bar, and here the output is, this is the OR invert. So A bar plus B bar whole bar, and then apply here the De Morgan's law, and see the values is A into B. So this one is work like a AND gate. And if you want to design a AND gate or OR gate, so you can choose here the values. Suppose that one X node is connected here, one X node is connected here, and it's the input is suppose A and B. So A is the input and B is the input, and again here you have connected one X NOR, one X NOR is connected. So if what is the output here? So A plus B bar, and then again here invert is connected. Output is A plus B bar whole bar, and this value is equal to, bar is cancel, A plus B, and it's work like a OR gate. So for the designing of OR gate, how many NOR gate is uses? So 1 and 2 NOR gate is used for the designing of OR gate. Similarly, you can choose another logic gate. Suppose I want to design the X NOR. Suppose I want to design the X NOR. X NOR. X NOR. So suppose I'm choosing one of the variable, one of the logic gates NOR is connected here, and it's the input is A, and another input is B. And what is the output here? So output is A plus B bar. So this is the output, and now here we have connect this one to another XOR gate, NOR gate, and this one is A is also the input. Similarly, here you have connect one NOR gate. This one is the input, and another input is B. And then here you have connecting one NOR gate. So this final output is XNOR. So final output is XNOR, XNOR, and its the values is called A XOR B bar, like this, and this values is only AB plus A bar B bar, AB plus A bar B bar. So what is the value here? So here the values is A plus B bar whole bar, so whole bar, and similarly here the values is B plus A plus B bar whole bar. And what is the value here? So here the value is just this plus this whole bar. Yes, this plus this into whole bar. So after simplifying, you got this one is the x NOR, x NOR. So how many NOR gate is used? So 1, 2, 3, and 4 NOR gate is used. And if you want to design the XOR, so what is the concept for the XOR? So XOR is, so first here you have designed the XNOR. First you have designed the XNOR, and then after that you have connect where NOR gate, NOR gate. So if here input is AB, if a output of this one, so what is the output here? So output is A XNOR B, and then apply the A XNOR B invert. So this is equal to A XOR B, and this is called XOR. XOR. So using this gate, you can design any other logic gates. So I hope everyone understood, or anyone have any doubts, any query up to this point. Everyone give your response. So anyone have any? So now we start the Karnaugh map.